and should be good. So the first one that they gave on the test, and I pulled questions from the exact test, so you will see these questions, and I hand wrote it all out, so hopefully you will be able to. 1, 0 is given. Find all the others. So this is the 0 they gave you, which is 3. And now you have to find the others. There's a couple ways to do this. I mean, obviously you could put it in your calculator. I'm going to tell you that all the multiple choices have square roots in them. So that alerted me that I'm probably going to have to use the quadratic formula. And so I was like, oh, great. But it's okay. We can do it. So the best thing to do would be take 3 just as it is and synthetically divide it into those coefficients. Now, again, make sure it's in order. So it looks like it's 3, 2, 1, and 0. So we're good. So 3, negative 19, 25, and 15. And then we bring down our 3, multiply, add, multiply, add, multiply, and we should get 0. And so what we've ended up with here is 3x drop by 1. So 3x squared minus 10x minus 5. And unfortunately, like I said, I looked at all the multiple choice, which gave me a hint that, I'm going to have to use quadratic formula. So quadratic formula, if you remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Double checking my dog is not going crazy. So negative b would be positive 10 plus or minus the square root of negative 10 squared is 100 minus 4 times 3 is 12 times negative 5 is 60. Yes, but it's negative 60, so I'd add that. All over 2 times 3, which is 6. So 10 plus or minus. Now this is the square root of 160, and that can be broken down into 16 times 10. And the square root of 16 is 4. And then you reduce that, and that would be 5, a 2, and a 3. And that's your answer. Your answers are 5 plus 2 root of 10 over 3, and 5 minus 2 root of 10 over 3, and the 3 also. So right off the bat, giving you quadratic formula to do. I was like, man, I wish it was easier. I was going to just punch it into Desmos. You could punch it into Desmos, but the Desmos will only give you the decimals. And specifically, they have all of the square roots there. So number 2, solve this equation. When you see a log on one side, you do that backwards C thing. When you have the log on one side, that's really what we would like. So you start here, you wrap around, and point. So this is really x. We're writing it as an exponential. We're changing the log into an exponential. So x to the power of negative 2 equals 49. Now, what does that really mean? Well, x to the power of negative 2 is really 1 over x squared equals 49, or 49 over 1. And then what I do is I cross multiply like this. So this would be 49x squared equals 1. And then divide by 49. And I get x squared equals 1 over 49, and take a square root. And remember, you would have plus or minus. The square root of 1 is 1. The square root of 49 is 7. But actually, it's not the minus because you can't have that base number be negative. So it's just positive 1/7. And that would be one of the choices. Okay, moving on. So they do have this one. Absolute values, this is going way back. Absolute value of x minus 2 minus 6 is greater than 9. And then absolute value of x minus 2 minus 6 is less than 9. It's the same question. Obviously, they're trying to see if you know the difference between less than and greater than. So things to remember about absolute values. You want your absolute value by itself on one side. So this 6 has got to go over there. So Add 6 would be 15, which would be the same on this one. All right, and then when you're working with absolute values, if it's a greater, it's an or problem. So you write it just like it is. You're going to write 2. Actually, you don't even need the absolute values, but you write x minus 2 greater than 15. Write it just like it is. Or start writing it again, x minus 2. Change the sign, flip the inequality, and change the sign to negative 15. You're going to do the same thing over here. When it's less than, you still write it just like it is. This is going to be an and problem, less than and. Then start to write it again, flip the inequality, change the sign. And then you just solve them. Each one, I mean, it looks like 4 problems, but you'll see it's the same numbers. So if you had solved this, you can have these, you'll just have some flipped inequalities. So add 2 would be x is greater than 17. Add 2, x would be less than negative 13. This one would say x is less than 17, and then this one would be x is greater than negative 13. Now, you have to write this. The multiple choice is in interval notation. So let's think of this in interval notation. X can be greater than 17 or less than negative 13. So that's really, if you're thinking about a number line, it looks like this way and this way. Negative 13 and 17. So you'd say from negative infinity to negative 13, and then united with 17 to infinity. However, this part, if I'm greater than negative 13, but less than 17, that would be the middle, because that's what an and is. An and is in the middle. The ors are on the outside. So that would be from negative 13 to 17. Okay? So first 3 questions right off the bat. Yay, fun, fun. Let him out, Judah. Let him out if he's crying for me, will you, honey? Thank you. All right. Next question, slope-intercept form. This goes back to chapter 1. So if you don't remember what slope-intercept form, again, write it down. Y minus y1 equals m times x minus x1. That's your slope-intercept form. You need a point and a slope to write any equation of line. That's actually, I take that back. This is not slope-intercept form. Your final answer will be in slope-intercept form. Slope-intercept form is y equals mx plus b. But this is always what you start off when you want to write an equation of a line. Okay, so we need to find slope. And slope is y2 minus y1 over x2 minus x1. So don't forget, this is an x1, this is a y1, this is an x2, this is a y2. So let's find our slope. Negative 8 minus 4 over negative 3 minus 4 again. What did I just do? I meant 0. Jeez, I saw my eye over there. Negative 8 minus 0 over negative 3 minus 4. So that would be negative 8 over negative 7, which is really positive 8/7. So there's your slope. Then you pick any of these points. I'm going to pick this one because I like the fact that it has a 0. And I'm going to plug it into this formula. That y stays the same. y1 is 0. Slope is 8/7. This x stays the same. This first y and this first x stay the same. And then that x1 is 4. And then you do have to clean it up. Y minus 0 is just y. Distribute 8/7 to x would be 8/7 x. Distribute 8/7 to 4 would be negative 32/7. So that is your final answer. I will tell you, for this question on the multiple choice, you could have really stopped right here because all the multiple choices, the slope, there was only one that had a positive 8/7. So I was like, huh. So I want you to be aware of that. You might not necessarily have to go all the way like I just did. You could have been like, oh, this was the only one that has an 8/7. Let me choose that one. You know, use those tricks because you've got to get fast. I think that's part of some of your problems. Some of you are like, Mrs. Seta, I worked so hard. I did all the work. I copied. I get that, but you got to go fast too. You got to be really thorough and consistent. Okay, number 5, identify vertical asymptote, horizontal asymptotes, if slant asymptote, if it has it, and the domain. And all the multiple choices are all of these within the multiple choice. So I'll start with vertical asymptote. Vertical asymptote looks like it's at -2, so it's written as x equals -2. Horizontal asymptote, well, there is none. So then this is a slant asymptote. And that's true because you can't have a horizontal asymptote and a slant asymptote. So it looks like it's going through the point, well, it looks like the parent function was y equals x, and then it shifted down to, or to the right to, however you want to look at it. So it looks like it's y equals x, and then it went down 2. Remember, y equals x looks like this. And then if I go down 2, that's where I'd be right there at -2. All right, and then, so now what's my domain? Well, I've got a curve here on this side all the way up until this asymptote at -2. So from -infinity to -2. And then I got a curve from the other, from -2 to +infinity. And like I said, that all of this would be in choice A, or all of it would be in choice B. Look for, you might even just have to find the vertical asymptote. Look at all the choices and be like, well, it's definitely not going to be A and C. You know, oh, it has an x minus 2, D has an x plus 2. You know, like, look for that. You might not even have to do all of it. Cool, buddy.
It's the candy cane. I crushed up the candy cane, and now I'm making this slushy.
Okay.
Where's the blender?
I have to teach. You're not using a blender.
No, Mommy, I need to use a blender.
Judah, I have to teach. I'm in the middle of teaching right now.
Oh, I'm sorry.
Thank you. Do not use a blender. No blender. Wait for Daddy. Thank you. Oh, gosh. If we hear a blender, you might see me run. Square root of 4x minus 3 equals 2x minus 3. They asked you to solve this analytically. I know some of you are like, well, I like to just put this equation and this equation in Desmos. And, I mean, again, you can do it. I'm just doing it what feels comfortable to me. To undo a square root, I square both sides. The square and the square root go away, so you're left with 4x minus 3. This you have to FOIL. Yes, you do, because it's a binomial. So FOILing it out would be 4x squared, minus 6 doubled would be negative 12x, and then plus 9. And then set it equal to 0. So this would be 4x squared minus 16x plus 12. I'm going to factor out a 4. Oh, see, this wasn't that bad. I mean, honestly, again, you could stick that in Desmos. You can find the zeros on the graph. You know how to do that now. So let's see, x minus 1 and x minus 3. Those two numbers multiply to 3 but add. And so x would equal 3 or 1. Now, the trick to this one, listen carefully. You could have extraneous roots, and you do, by the way. Anytime with square roots you have extraneous, you could have extraneous, and even with fractions. So if you plug a 3 in, 3 would be 12 minus 3. The square root of 9 is 3. And then plug 3 right here. 6 minus 3 is also 3, so that works. But if you plug 1 in, you get the square root of 4 minus 3, which is 1. And if you plug 1 on this side, you would end up with a negative 1. Remember, I'm plugging it into the original. So this one is extraneous. So your only answer is 3. And I'll tell you, when I looked at the choices, they have both 1 and 3. So you might be like, oh, I'm going to choose 1 and 3. But it's extraneous. So be careful. All right, number 7, solve this nonlinear system. I would say let's go straight to Desmos on this one because Desmos makes it much easier and nicer. And I've kind of already plotted them in here because I was kind of looking at it. There's x squared plus y squared equals 68. And this is x minus y equals 10. And then you're finding solving the system. So you're finding those two intersection points. So negative 2, 8 and negative 8, 2. It's very quick and very easy in Desmos. Just, move your cursor out and find the points of intersection. The graphing calculator would take a little bit more time because you would have that square root to deal with and you'd have to solve for x. So this one just really, really nice. So let me write this down. Negative 2, 8 and negative 8, 2. And that's in Desmos. And I'll just go back to my picture here. Okay. So first 7 questions, I don't think, again, anything too crazy so far. Okay, number 8. Solve x plus 4 squared equals negative 5. And they actually asked you to use the square root property on this one. What they mean is the following. You could FOIL this out, bring the 5 over and set it equal to 0. But what they really just want you to do, and it's much quicker this way. How do you undo a squared? Square root. Those cancel. You're left with x plus 4. The square root of negative 5, remember, is that I stuff. So you would pull out the negative and you go I, and then you'd be left with square root of 5. And then whenever you take a square root, you always have plus and minus in front. So that's another thing you don't want to forget, a plus and minus in front. And then that 4, you just subtract it over, and we like to put it in front of the plus and minus. So when I subtract it over, it'd be negative 4 plus or minus I square root of 5. Done. I think that's much easier than if I tried to set it equal to 0 and stuff. All right, given, they're going to give you a parabola, and they're going to say sketch the y equals negative f of x. Now, we all know what a negative on the outside means. It means it reflects over the x-axis. So what maybe you don't understand, and this actually tricked me up for a second too, because I thought it would just go upside down from the vertex for a second, and I had to think about it. So I'm thinking maybe if I got that wrong in my head, you would get that wrong too. So this is actually the negative of y. So you want your y value to turn negative. So if I had negative 5, negative 3, which is the point, they'll give you that coordinate, by the way. It would be negative 5, positive 3 would be the new vertex. And up to 3. And then it would flip upside down. Okay. So just be careful about that one, because I think that's an easy question. Like I said, I almost made the mistake because the choices were, one of the choices was just upside down like this. I knew it was upside down, but at first I picked the wrong one, and then I second guessed myself, and then I was like, oh my gosh, this is negative y, so it goes up here. So be careful of that, but you'll see it's all multiple choice, and it's all different, 3 different pictures. 2 of them are up and 2 of them are down. We knew it was down, so we had a 50-50 shot, and then we just work it out. All right, number 10, solving systems. Now that you've learned about the beauty of RREF, and I have to say, oh my gosh, I'm just aware that Desmos has a matrix calculator. I did not know this. Desmos, you are coming through for me. If you want me to show you, I will afterwards, but I'm not, I'm still learning the kinks of it. It's not that hard, honestly, but I prefer my calculator, so I'm going to show you how to do it on the calculator. But just to refresh you, we need to make an augmented matrix and just write all your coefficients, 9, 6, 48, negative 5 to negative 48, and then go to RREF in your calculator or on that Desmos matrix calculator. But I'm going to show it to you on my calculator. And so I go second into the matrix, And this is a 2 by 3, which my B is already a 2 by 3, so I might just edit that one. So I'm going to go over to edit and edit my B. 2 by 3. I'm going to change the numbers to 9, 6, 48, -5, 2, and -48. Let me make sure I wrote that right. Go back to the home screen. Go back into the matrix. Again, to get to the matrix, you hit second and then the button underneath the word math. And then you go to the math, over to math, and you go up to RREF, not REF, RREF. You go back into the matrix, go down to matrix B that we just did, and hit enter. And remember, the diagonals along the ones, that's what you want. This one refers to X. The second one refers to Y. So X is equal to 8, Y is equal to -4. And they write it as a solution. So, like I said, Desmos has their own matrix calculator, and I was like just introduced to this. Telling my math friend about this, I'm like, I cannot believe. I know Desmos is becoming so amazing. All right, I'll be honest with you, I cheated here and didn't write the whole question because I was getting tired of writing already at question 11. But it's about a rocket being propelled upward from the top of a building at 120 initial velocity. They're telling you all this stuff, but really the important part is this function right here. And then the question says determine the max height. So what I would do for this rocket question is put this in Desmos, -16t squared plus 128t plus 120. I think I already put it in, did I? I did. And you can see it's out of my viewing window. But if I scroll up, ooh, it's pretty high. There it is. You can kind of see it. I mean, you could change your window if you want to, but if you just click your point right there, you can see you have a max point at 4,376. 4,376. So at 4 seconds, you have a maximum height of 376. So for 376. But which one of these is your maximum height? The maximum height is 376. This is the time. This is the actual height of that time. So 376 is your maximum height. Okay, I'm going to come back to 12 because it's saying to do it non-analytically. Well, actually, I can do this one analytically, and then these two it's supposed to be doing graphically. So I was typing into Desmos, and it wasn't working out for me in Desmos wise, so I want to kind of fix that on our break, but I will come back to this. So have no fear on 12 yet. I will not leave you stranded. But I want to get through this one, 13. So this is 3 to the 7 minus 4x equals 1 over 243. So if you don't know this, 243 can actually be written as a base of 3. 243 is actually 3 to the 5th. So 1 over 3 to the 5th, which means that you can write this side right here as 3 to the -5, because 1 over 3 to the 5th is the same as 3 to the -5. And then this would be 3 to the 7, just to show you, 3 to the 5 is 243. So now that they're the same base, like don't do the whole, you could do LNs, don't get me wrong, you could, that just takes so much time. If you can get them to be the same base, do that. And that's why I knew 243 had a base of 3. And just check anyway, just start plugging in some numbers, 3 to the 6, 3 to the 4. Once they're the same base, you just set the exponents equal. So -4x equals -12, x is 3. And that is the solution. Okay, you do have a difference quotient question on here. It's been a while, and it's a quadratic too. We did a couple long time ago questions on difference quotient. If you believe you me, you will do this in calculus quite a bit, difference quotient. So let me explain. They actually give you the difference quotient. This is the difference quotient, f of x plus h minus f of x over h. And they want you to find the difference quotient for f of x being 4x squared plus 9x minus 1. So let's figure out what we have to do first. So this, I'm going to do this one first. F of x plus h. I'm going to write that down over here. F of x plus h means everywhere you see an x in this equation, you're going to put in x plus h. So everywhere I see an x, I'm going to rewrite 4x plus h squared plus 9x plus h minus 1. Now you have to clean this up. This one is something you should almost like memorize, but you have to FOIL this out, and this will always come out to be x squared plus 2xh plus h squared. And then you multiply it by the 4. So that would be 4x squared plus 8xh plus 4h squared. And then you distribute this guy. So 9x plus 9h and minus 1. That right there is this green box right here. These two are the same thing. The minus f of 8x, excuse me, I'm going to change my colors here. Well, that f of x is right here. So you're going to, onto this long thing, you're going to subtract that guy. Well, what I tell my students is to do is to distribute while you write. So distribute that negative. So negative to 4x squared would be negative 4x squared minus 9x plus 1. And then the difference quotient ends with all over h. All over h. Now, can we clean this up? We sure can. And this will always happen. Things will go away. 4x squared minus 4x squared goes away. Positive 9x minus 9x goes away. Negative 1, positive 1 goes away. That function should go away. And so what are you left with? You're left with 8xh plus 4h squared plus 9h all over h. So we're going to reduce everything by an h. So if I reduce that by h, I would have 8x. Reduce that by h would be 4h. And then reduce that by h is 9. And that is the difference quotient. And that will be in the multiple choice for this. Very consuming. I'm going to let you know you're going to have one just like this. You might have a 2 here and a 3 here, but it's going to be same thing. Because I've run the test a couple of times, and it's always been this kind of trinomial, but it's really the same exact thing. It's always going to be take that long polynomial, subtract it from f of x, and divide everything by h. Especially if you're going to calculus, this is really necessary. You'll know when you reach the calculus. 15, find the f of the g. So what does that mean? That means, and they'll give you an f of x and a g of x. That means take your g and plug it into the f everywhere you see an x. So take this entire g function, plug it into the f function where you see an x. So this would be the square root of, instead of x, put 8x minus 14, and then plus 10. And then reduce. This would be 8x minus 4. And they do clean this up a little bit more, meaning the following. So watch what I do. They factor out a 4. If you factored out a 4 from 8x minus 4, you'd have 2x minus 1. And then you are allowed to take the square root of 4 and pull that outside. That would be 2. And then this part right here would stay underneath. And that would be the answer. And that's the answer they have. They don't have this one. They have this one. So, all right, moving along. 16, determine the vertex. See if I can pull this up a little bit. So they give you this table, and they want you to determine the vertex, identify the vertex max as a max or min, find the max or min value, and then tell me the range. So I'm looking at this and I'm noticing I'm like 29, 29, 15, 15, 9, 9. Oh, this one doesn't have a pair. That's because that's the vertex. -3, 7, it's the vertex. Now, is it a max or min? Well, the way that I do it is I kind of have to look at it, to be honest with you. I kind of have to plot it in my head. So if I know I'm at -3, 7, I'm up here somewhere. And then I usually plot these two numbers next to it, like this is -3, so -2, 9 would be up, and -4, 9 would be up. So I kind of know already it's going to be like that. So is that a max or a min? Well, that's definitely a min. And then it says, okay, well, find the max or min value. The value for the max or min is not the x value, it's the y. It's just like the rocket ship one we just did before. You pick the y part. So the value is 7 at the point -3. And then what's the range? So, well, if this value is 7, my range would then be as low as 7 and up to infinity. So my range would be from 7 up to infinity. Okay, moving on. Like I said, we'll take a stop at, after this page, we'll do one more page and then we'll be halfway through. All right, f of x equals x squared minus 64. G of x is 2x plus 3. What's the domain of f over g? So this one's not too hard. You know, if you put f, which is x squared minus 64, and you stick it over g, you create this new function. Well, in a division of functions, your domain, anytime you have a fraction, guys, your denominator can't be 0. Can't be. These both have domains of, you know, from -infinity to infinity, because this is linear, this is quadratic. But you can't have a denominator 0. So that right there can't be 0. So we're going to do something weird. We're actually going to solve it as if it was 0. So I would subtract the 3 over and divide by -2. So what that means is x can be anything but -3/2. It can be anything but -3/2. So how do I write that with interval notation? Well, I can go all the way to -infinity up to -3/2, but I can't include it. And then I can even go the other way. I can go all the way to positive infinity, but I can't include 3/2. So this is the domain of that function. So you look to see where it's 0, and then you pretty much say, well, it can be everything else. So that's how you would solve that one if you were given domain of a f over g. All right, number 18, find f -1. What is that? Well, that's inverse. And what does inverse do? Well, inverse is you flip the x and the y. So everywhere I see an x, I'm going to write a y, and this right here is a y, I'm going to write x. Now, how do I solve for y? Well, you're going to get y by itself. First of all, I don't like the fraction, so I'm going to go like this. I'm going to put this over 1. I'm going to do my little crisscross like that. Of course, I kind of colored into it, but x times y plus 5 equals 1 times 3y minus 2. Distribute that x. And now, again, you're solving for y, so you want to get y by itself. So if I get y by itself, really, these two would just switch. So let me move it up here. I would have xy minus 3y equals negative 5x minus 2. How do I get y by itself now? You factor it out. And now that y by itself, you just divide by that. So y equals, now I'm going to stop right here because it tricked me. This was not one of the answers. But the exact opposite signs was one of the answers. So just to let you know that, they decided to change this to a positive 5x, change this to a positive 2. Then they changed this to a positive 3 and this to a negative x. And that is the inverse. So, sorry to tell you that. You'll be on the right track, though, if you solve it this way. This is the same. These two are the same. This is just the, like, opposite form of it. So, but it all works out. Number 19, more domain questions. F of x is 2x minus 5, and g of x is x plus 10. What's the domain of Goff? Okay. So the domain for this one, again, is all reals. The domain for this one, again, underneath a square root, you cannot be, you have to be bigger than 0, bigger than or equal to 0. So I know that right here, x has to be greater than or equal to negative 10. But if I Goff them, okay, so what does Goff mean? That means take the f and put it into the g. Take this entire function and put it in right there. So this would be the square root of 2x minus 5 and then plus 10, which is the square root of 2x plus 5. Okay, so again, this underneath is not allowed to be negative. It's got to be greater than or equal to 0. So solve. So x has to be greater than or equal to negative 5/2. So how do I write that in interval notation? So greater than or equal to would be negative 5/2 up to infinity. So just real quick, just go over this. They've done 2 domain questions of functions. One where you'll have a fraction. Denominator can't be 0. So you set it equal to 0 and say, I can be everything but that. Then they give you another one with domain of a square root. They're always going to do that with square root. So you Goff it and then set what's underneath, if it's a square root, greater than or equal to 0. Okay, so I felt like I kept seeing that a lot here, this domain idea. So make sure you kind of go over that. One was a fraction, set the denominator equal to 0. One is a square root, set what's underneath greater than or equal to 0. All right, back to 20. Factor p of x into x cubed minus 75x minus 250 into linear factors, given k equals negative 5 is a 0. So again, I say for this one, so they give you all the multiple choice again, and I noticed that all the numbers looked like factors that I could get from Desmos. So I'm going to go to Desmos and go like that real quick. And I'm going to type this in. So x cubed minus 75x minus 250 And yeah, I got to stretch it out a little bit. You can pull that down. Okay, so let's go over this. See, like, this is really cool. This right here is at the 0, -5, which they told us, actually. They told us -5 is a 0. But notice it's touching. Do you remember that if it's touching, it has a multiplicity of an even multiplicity? So it's touching at -5, and then look, it's crossing through at 10. Touching at -5, crossing through at 10. Let me go back to my picture here and kind of show you this idea of what I'm doing. Because I'm trying to save you time, guys. You got a lot of time here. So this was -5, and this one was 10. So if you are crossing at, if you're touching at -5, that means x plus 5, remember you changed the sign, is a factor. And if you touch, you have an even multiplicity. So since this is degree 3, this is probably going to be only as high as 2. This one is crossing at 10. So that would be the other factor. And there you go. I've just factored this into linear factors. There's your linear factors right there. And I didn't have to do, I think, honestly, what I think they wanted you to do is do the whole, and you can do synthetic division. You can divide by -5. And you have to be careful here, though, because your coefficient would be 1, then your squared would be 0, -75, -250. And then you get a quadratic, and then you factor that. And you can do that. You can totally do it. But I kind of was like, you know what? If I can use Desmos, let me look to see where it's touching at -5. Oh, then the factor is x plus 5 squared. Oh, it's crossing through 10, x minus 10. And you can see those choices there too. Alrighty. Let's do one more page and take a break here. Oh, of course I have to do this one. That's all right. This is a long one. I wrote it all out for you, but it's actually not that terribly hard. My thing is all stuck here. Oh, well. A piece of cardboard is twice as long as it is wide. You're going to have one like this, by the way. It is made into a box with an open top by cutting 5 centimeter squares from each corner and folding up the sides. Let X represent the width of the piece of cardboard and determine the volume in terms of X. Determine the volume. Okay. So, of course, I didn't leave myself really that much room. Great. That's all right. I'll kind of squeeze on over here. So you have this piece of cardboard. And you've cut 5 centimeter squares. 5, 5, 5, 5, 5, 5, and 5, 5. Because you're going to fold it up. Okay? And you're told that piece of cardboard is twice as long as it is wide. And you're told to let X be the width. So I'm going to let X be the width. So if it's twice as long as it is wide, this would be 2X. Now, actually, I should have kept this in green so you can see what I'm about to do. So remember, we're cutting these little 5s out, and we're going to have this length right here by this length right here when I fold it up. This by this would be my base right there. So if I cut this 5 away and this 5 away, this would be a dimension of 2x minus 10. This way, the width way, if I take 5 and take 5, then I would have x minus 10. So let me draw it a different way for you now. So here's my box. Okay. And I know this height right here is 5. Each one of these little corners is 5. And then this new width and new length would be 2x minus 10 and then x minus 10. And now the question says, okay, determine the volume in terms of x. If you don't remember what volume is, it's pretty easy. It's just length times width times height. So 5 times 2x minus 10 times x minus 10. And you have to FOIL it out. I hate to tell you that, but they made the final answer in a FOILed out form. And I'm just going to tell you it's 10x squared minus 100x minus 50x plus 500. By the way, just to prevent anybody from making this mistake, you only distribute 5 into one of these, and then you FOIL it with this one. Do not distribute 5 into everything. You only do 5 times 2x is 10x, 5 times 10 is 50. Take that, 10x minus 50, and then multiply it to the x minus 10. And that's how you'll get. That's the volume of the box in terms of x. All right. Heading to the end here, 22 says, tell me, is it a circle or a parabola? And, you know, you could say x squared plus 4x plus y squared plus 10y, and then minus 44 and set it equal to 0, and put it in Desmos. And I'll tell you right now, it will be a circle. I will let you know though, when your x squared, when you have an x squared and a y squared, and they both have the same coefficients, it's always going to be a circle. It will only be a parabola if you have one x squared or one y squared. So that was pretty easy. All right, and 2 more here. Write f of x equals 3x squared minus 4x in the form of, so they want you to write it in what's called vertex form. So I hate to tell you, but you got to complete the square for this one. It's not terrible. I mean, I'm sure there's multiple ways of doing multiple choice. I'll just show you again, refresh you on how to complete the square. But what you do is you set this equal to 0. You are not allowed to have a number in front of your x squared, so you have to factor it out. When you factor it out, it divides that middle. So this is actually a terrible completing the square. And you put plus blank, and then over here you put plus blank. So again, I factored out that 3, and I divided that 4 by 3. Now, if you don't remember how to complete the square, you take half of this middle and square it. So you're probably like, how do I take a half of 4/3? Well, 4/3 times 1/2, your fraction rules, it's 4/6 or 2/3. And then you square it, and 2/3 squared means 2/3 times 2/3 or 4/9. But you don't put 4/9 here, because remember you took out a 3. So you have to bring it back in. And 3 times 4/9 would be 12/9, which reduces to 4/3. Now, how did that even help you? So this would be 3. Remember, we're trying to make it look like this. 3 would be the A. X minus h squared, so x minus, your h is whatever you took a half of, squared. Yes. And then your plus k, well, the k is on this side, so we have to bring it back over. So we have to minus that 4/3 back over. And that is the completing of the square. Are there other ways you could have done this? To be honest with you, if you have the time, you know, you're trying to be careful about time here, but you could probably put this into Desmos real quick, and then they're going to give you 4 multiple choices. Put all 4 of them into Desmos real quick. There's several options here, but you got to be careful on time. Don't get stuck on one question like this because you're like, I'm going to put them all into Desmos, and you've wasted time. Okay. All right, 24, and then we'll take a quick break. Find the f of 2. They're going to give you a function, piecewise function. So where do you plug 2 into which piece? Well, this says a 2, but it doesn't say equals 2. This has a 2, and that's where it would go. It would go into this piece right here. You plug 2 into the x, so it would equal 4. Okay. Okay, everybody, I'm going to go back to 12 because I just looked at the problem and I was reading the multiple choices wrong. I was like, how is the answer a 3 and a 125? But they put a space there and it was 3,125, which is where I led my mistake wrong. So let me share my screen with you and then I'll talk about number 12. Here we go. There we go. 12 is this type of question where it has this idea of they give you f of x being 15 minus 3 log base 5 of x equal to 0. And then they also want you to find when it's less than 0, when it's greater than 0. And they ask to do it graphically. They ask to do this one analytically and then this one, these two graphically. That's why I kept getting it wrong. I'm like, it's not working because first of all, I didn't even follow through and I just was reading it as totally different. But if you were to solve this, 15 minus 3 log base 5 of x equal to 0, what I would do is just, subtract 15. So negative 3 log base 5 of x equals negative 15 and divide by negative 3. And then when you have one log on one side, you do that whole zoop. So 5 to the 5th. If I had just done this, I probably would have figured out 5 to the 5th. I couldn't figure out what 5 to the 5th was, but it's 3,125. But the way that it made it look like it was like 3 comma, and it had such a separation here that I was not even putting it together. That's what happens when I teach all day. But this is where the function is equal to 0 at 3,125. Now we need to see when is this function less than 0 and when is this function greater than 0. So what I've done is I put this into Desmos, the 15 minus 3 log base 5 of x, and being that it's all the way out here to 3,125, you'd have to change this settings window. Your x-axis, my x-axis is from 100 to 5,000 with a step of 1,000. I mean, that's a very large number. You have to kind of change it just to see. So this black line is that log, that f of x line. So for the first question, when is f of x? Let's find our intersection point right here. So when is f of x less than y equals 0, which is the red line? When is the black less than? And you can see the black is less than for all values of x greater than 331.25. When is it less than? So from 3,125 to infinity. And then, and I just want to let you know, it looks really weird in my math lab. Like the comma, like they put a comma here. So it looks like 3, 125. That's why I was like, what is my math lab doing? But that's for that one. And then for this one, when is it greater than? When is the black line? The black line you can see is greater than the red line on this side of the 3,125. So from negative infinity, well, actually, I take that back. It would be from 0, because you can't have x value, obviously, in a log. So it would be from 0 up to 3,125. Remember that about, you can't, like, look at this. There's an asymptote there. So from 0 to 3,125. Okay. And that's all you had to do with that question. Again, my bad on reading it wrong, but I think if I read it wrong, then maybe someone in here would read it wrong, and that's why we do this. Okay, let's go back to 25. I know I'm going slow, but again, many of these you can get quicker. 25, solve the equation. Absolute value equation, you want to get that absolute value by itself, this part right here by itself, so minus the 5 over. So I'm just going to distribute while I'm here. Equals 3. And this is really the absolute value of 2x plus 1. Remember, with absolute values, you have to write it twice, just like we did with the inequality. So 2x plus 1 equals positive 3. 2x plus 1 equals negative 3. And solve. And you would get 2x equals 2, x is 1. And 2x equals negative 4, so x is negative 2. And plug them back in 2, but they both work. Solve in terms of y. This is a matrix again. So we're going to put that into the matrix. I'm going to come back to this one because this one's going to take a little time. I want to get as many done as I want, but I'll come back to this one in a second. Find the domain of a log. Okay, so this is why I got stumped up on number 12 for a second. Anything here after the log, anything next to it. That's why at first I was like negative infinity. I'm like, no, it can't be, because anything after a log has to be greater than 0. So this 81 minus x squared has to be greater than 0. And that factors into 9 minus x and 9 plus x. And that is, remember doing this quadratics with greater than and less than? This is on a number line. And so you would put negative 9 and 9, and you would test the zones. And so you'd plug a number in, and remember, if it's positive here, it would go positive, negative, positive. So really, you just have to test one zone. So I'm going to test 0. So if I plug 0 here and 0 here, it would be positive. So I know that in the middle is positive. And then these two would be negative, because they alternate. So where is this greater than 0? Where it's positive. So between negative 9 and 9. Between negative 9 and 9. And when it equaled, you can't equal 0. You don't want this to equal 0. So it's always going to be greater than. Okay, 28 is sketch an inverse. They give you multiple choice for this. Inverse, remember, is flipping your x and y. Also, inverse, though, is if you just can draw in your head this y equals x line and think about folding this piece of paper over, that's what would happen to this sketch. Okay? This point right here, I don't know, let's suppose that point is at the point, 0, 2. Well, now it would be at the point 2, 0. The x's and y's flip. So it's going to go like this. So this will go here, and I drew this kind of terribly, but it will go right through that y equals x line. And you'll have multiple choices for that. Alrighty. Got to come back to that page. Oh yes, this one. They love this one, and many students have asked me on this one. Just so you know, it happens. This one looks so complicated. Log base 4 of x squared minus 2 log base 4 of x equals 8. This is one of those times where we did that whole u stuff. We said let u be log base 4 of x, because then this right here is u squared. And then this right here you can write as 2u. And then if I minus the 8 over, oh, look at that. It looks like a trinomial that I can factor. So then I would go two numbers that multiply to -8 but add to -2 would be 4 and 2. And then set this equal to 0, so you'd have u equals 4 and u equals -2. But remember what u was. U was log base 4 of x. And so rewrite the u log base 4 of x. And then do the whole zoop. So this would be 4 to the 4th equals x. So x is 256. And this is 4 to the -2, which is 1/16. So there's your two answers. So you're going to have a question like that, this understanding of a trinomial. Number 30, you had to classify this as conditional identity or contradiction. So what does that mean? So an identity is when you get out something like 2x plus 7 equals 2x plus 7. It's exactly identical, okay? Contradiction would be where you get like 7 equals 5. You know, it contradicts itself. So if you start solving, and let's see, you get 4x minus, no, not minus 12, plus 12 equals 4x plus 24. Well, that's not true. Okay, they're not identical. Okay, they're not a conditional. It's a contradiction. My husband and son are wrestling, so I'm sorry it's loud right now. Okay, then you'll have a question on expand. I'm actually going to shut my door. Okay. So expand with logs. Start with the division. And actually, I would rewrite this as 16x to the 1/2 over y. You want to write it with that power because there's power rules there. So when you divide, you subtract logs. So this would be log base 15 of 16x to the 1/2 minus log base 15 of y. Now this is a multiplication. So you need to separate this. Log base 15 of 16 plus log base 15 of x to the 1/2. And then just keep writing minus log base 15 of y. So we had a division and a multiplication in one. And then the only last step would be bring this power down. So log base 15 of 16 plus 1/2 log base 15 of x minus log base 15 of y. And that's your answer there. So don't forget that. What is this question asking us? Oh, so it gives you a graph and it says, where is it increasing and where is it decreasing? So remember, you start your graph from the left. Your pen goes from the left. And my pen is going up until where? On the x. On the x, not on the y, even though I drew in the y. So it's increasing from -infinity up till 0 on the x. Then on this side, it decreases from 0 to +infinity. And actually, they use brackets, which I think is very weird because most books don't use brackets with increasing or decreasing, but they did for all of the answers. And that's okay. find all complex solutions of x to the fourth plus 7x squared minus 18. Again, this is a trinomial, so it's probably factorable. Instead of writing x and x, you put x squared. Two numbers that multiply to negative 18 but add to 7. 9 and 2. And then the 9 would be positive, the 2 would be negative. And then you set each one equal to 0. So x squared equals negative 9. Take its square root. X equals plus or minus. The square root of negative 9 is an I, and the square root of 9 is 3, so it's 3I. Plus or minus 3I is the 1. Do the same thing over here, add 2, take a square root. X equals plus or minus, there's no I here, so it's just square root of 2. So there's your 4 answers. Degree 4, positive I, negative 3I, positive square root of 2, negative square root of 2. 34, good old synthetic division. Again, I would just make sure that you have these numbers in order, which we don't. We're missing a 3 and a 1. You have to change this sign when you do the synthetic division because it's in a factored form. If it wasn't in a factored form, you don't change the sign. So 3, 4, there is no 3 term. There's a 2 term. There is no 1 term. And then the constant. And just to go over synthetic, drop it down. Add would be negative 2, would be 4. 12, negative 24, there we go, negative 25. But you have to write this as a polynomial, the answer. So the answer would be this down by degree. So 3x to the fourth, 2x cubed, 4x squared minus 6x plus 12. And then this is your remainder, which goes over what you divided by, which was x plus 2. And that is the choice. That's how they're going to write it. Okay. The graph of y equals absolute value of x is vertically stretched by a factor of 1.8. This graph is reflected across x minus x-axis and shifted downward 0.72 units. And they want you to give the equation. So we know how to do this. This isn't hard. Vertically stretched, that number goes outside of the parent function, like on the front. So we know that that's where the vertical stretch would go. Graph reflected across the x would be a negative on the front. And then shifted downward, well, that's also outside the parent function, so you write minus 0.72. And like I said, they'll have choices for all that, so easy breezy. So see, some of these questions are super easy. All right, is the relation a function? If it's a function, your x's can't repeat with different y's. And look at that. Not a function. X's repeat. Boom. Boom, boom, boom. We've gone through a couple of them. Oh, $2,000 invested into an account that pays interest compound continuously. How long will it take to grow to 6,000 at 6%? Okay, so compound continuous is a PERT. P-E to the RT. So what am I putting in? I'm investing 2,000 at a rate of 6%, so E to the 0.06. We don't know how long t is. We'll call it t. And I want it to grow to 6,000. So we're going to solve for t. So divide by 2,000. 3 equals e to the 0.06t. Do you remember how to undo an e? You ln it. So you're going to ln this side and ln this side. And the ln and the e cancel. And you're left with the ln of 3 equals 0.06t. And then divide by 0.06. So ln of 3 divided by 0.06 is so about 18.3 years. And that's how you'll do that one. Find p of x with given zeros at 3 and 4i of the least degree. So you would say x minus 3, since that's a 0. X minus 4i, since that's a 0. And then don't forget its conjugate, negative 4i. So you would also have x plus 4i. They always will do that to you. And then you've got a FOIL. So foiling this would be x squared. Remember, you just really have to do the first and the last. And negative 4i times a positive 4i is a negative 16i squared, which I squared is really negative 1. So this is really I squared plus x squared, excuse me, plus 16. And then you multiply it with the x minus 3. And you will get x cubed minus 3x squared plus 16x minus 48. All right, 39, it's giving you multiple choices for the piecewise function, and it's just familiar things that we know. This is the x squared function, but it's been shifted down. So I know it's, x squared minus 2 is this one of these functions. The other piece, this is a constant function at 1, 2, 3, 4, 5, negative 5. And then you just have to write the second part, the domain part, restricted on that. So my domain, my x values for this quadratic right here is anything greater than or equal to 0. Whereas this negative 5 is anything before 0, anything less than 0. And obviously those should be flip-flop because we always want the less to be on top and the greater than be on the bottom, but you can see the multiple choice which one that'd be. And you'll get questions just like this. You'll get nice, easy, like quadratics that have been shifted or constants that are moved. Okay, this question, it's not 3 parts. I'm just trying to give you the multiple choice just to show you how easy it is. There is a hole in the graph at x equals 5. Which one of these has a hole in the graph at x equals 5? If you have a hole, then you have a factor at x equals 5 that cancels. So if I'm looking from top to bottom, these two cancel and these two cancel. Obviously nothing cancels here, so it's not choice A. But is it the x plus 5 or is it the x minus 5? Well, remember, change the sign. So this would cancel with this one. And that would be the one. C is the one that has a hole in it. So you would, again, you have multiple choice here and you have to pick the one that has a hole in it. All right, down to like final 10 more. We can do this. I know it's probably been the longest you've ever done with me, but it's okay. It's before the final. Solve. This one's easy. Negative 6x minus 39 is less than negative 9x minus 15. Add 9 would be 3x, and then add 39 over would be, oh, I think it's 24. X is less than 8. Oh, but you have to write it in interval notation. So it'd be negative infinity to 8. And that would be your answer. Given, they're going to give you a picture here, and they want you to sketch the absolute value of that picture. So remember, with absolute value, it makes all the y values, these two parts right here that are negative, it makes them become positive. So it goes like this. That's literally, that weird W right there would be the shape of it. And that would be your choice. Okay, 43. This is a little bit of a time consuming, but I'm going to set it up for you and you can do it in your spare time there. Linda invests $25,000, part at 5%, part at 6%, and part at 8%. So remember, this is when we did those triple equations. So I make a box. I do 5%, 6%, and 8%. And you need the amount times the rate at which you're doing it, which really is all of these, 0.05, 0.06, and 0.08. And we need to then get a total. Okay, so the total income from all is $1,600. The combined income from 5% and 6% is the same as the income from 8%. So, meaning, if I call this X and Y, so whatever I invested at the 5% X and 5% Y, the combined income from 5 and 6 is the same as 8. So this would be these two together. And then you multiply across. And then this would be 0.08 times X plus Y. Now, you have to write two equations from this. So your equation is always the amount one, this one right here, and then the total one, okay? So the amount that she invested into all of these was $25,000 according to the story, right up there. The total income she got was $1,600. So you would create this equation, X plus Y plus X plus Y equals 25,000, which is really 2X plus 2Y equals 25,000. And then this one would be 0.05X plus 0.06Y, and then distribute that, plus 0.08X plus 0.08Y equals 1,600. And then you would clean that up to be 0.13X plus 0.14Y equals 1,600. And then this, my friends, is an RREF. And if you reduce row echelon form it, you'll be able to solve what you got at each percent. So you can do that on your spare time, but at X you would get $10,000. You would invest at the 5%. The Y would be $5,000 at 6%. And then you should be able to solve the rest and whatnot. All right, let me move on. Determine the system of inequalities. Oh, they give you a picture, and what they're just trying to see is if you can understand the shading inside of here. So this is, you all know, this is a quadratic. It's an upside down quadratic. It's been shifted up 4. So we know it'd be negative X squared plus 4. And then this is the Y equals X line. This is the Y equals negative X line. Okay, but if you notice, So if I kind of, let me call this the green one right here. So I want above the y equals negative x line, I want it shaded above. So I want that to be greater than. Whereas this parabola, I want it shaded below, so I want it less than. And that's your answer. Again, you could go through each one and, graph them by hand on Desmos, but not worth it, not worth it. What do we got going on here? All right, 45. 10 over x minus 2 equals 1 plus 12 over x plus 2. So this is a fraction that you have to find a common denominator for. The common denominator would be both of these. So you want to multiply everything by x minus 2, x plus 2. This is how I do it. X minus 2, x plus 2, and even this one. And then this cancels with that one. And you're left with 10x plus 20, 10 times the x plus 2. X minus 2 times x plus 2 is x squared minus 4. And then those two cancel and you're left with 12x minus 24. And then, you have to solve this. It's an x squared, so set equals 0. And you get x squared plus 2x minus 48, which you'll factor and get x to be negative 8 and 6. So, and both of those will work back into that equation. You won't have any problems here. All right. Square root of 16x plus 32. Rewrite and explain the transformations of y equals square root of x. So what they're trying to do is they're wanting you to like factor this. You could factor out a 16 on the inside. If you factor out a 16, you'd be left with x plus 2. And then the square root of 16 is 4, so I can bring the 4 outside. So what does this really mean? Well, this in terms of transformations would be a vertical stretch by a factor of 4. What is this on the inside of the parent function? Well, that means that I went to the left 2 units. And that's the choice that you would have. But the extra stuff that you have to do is just kind of factor out that 16 and refactor it out. All right, we're getting done, I promise. Look, we're almost done. 2 pages. Bear with me. I know it's rough, but it's the final. We have to get, it's the final countdown here. We got to get done. Solve this equation. What does a minus mean with logs? You want to condense this before you start solving. Minus means to take the log and the first one you see and divide by the second one you see. And then since we have a log on this side and a log on this side with the same base, you can kind of ignore it and you just set these two equal to each other. So 3 plus x over x minus 5 equals 3 over 1. And then, I like to do this. This is my favorite thing, crisscross multiply. And you get x to be 9. You can double check my work. 48, really easy question. It's just standard form for i's. So you always combine your real numbers together. That would be 8. And then you combine all your imaginaries together. So negative 9, positive 6i, and negative 4i would make negative 7i. And that's the answer. I hope you get that one on your test. You should get all of them on your test. Yay, last and final few, but I think I had one more to go back to, which I might just save for the next class, or I'll take a picture of how to do it in a minute. Well, no, we have time. I know it's been late, but we're doing good. All right, solve this by graphing. This is that zone stuff again. You got to understand how to do zones. So you plot all your zeros. So you'd have a 0 at -2, -3, -4, but make sure you go in order. And you pick numbers inside of these zones. So if I picked like -5 and I put it here, I would have a negative times a negative times a negative. 3 negatives make it negative. Oops. If I pick a number in between -4 and -3, that would be -3.5. I would have a positive, negative, negative, and 2 negatives make it a positive. And you keep doing that. Pick -2.5. You'd be positive, positive, but negative. 1 negative makes it negative. And then pick a number greater and you would have all positives. Now that we have our sign test, we're going to answer the question. Which one of these is greater than 0? Greater than 0 means you would have to be positive. So here and here. So your answer would be from -4 to -3, united with -2 to infinity. And that's as easy as that question is. Okay, this one, 1 minus 16 over x plus 81 over x squared. Again, common denominator here is x squared, so I'm going to multiply everything by x squared. Even the 0. 1 times x squared is x squared. X cancels into x squared with an x remaining, so it's minus 16x. And that cancels and leaves you with 81. And that's 0. And hey, that looks factorable, which it is. But unfortunately, it's factorable with quadratic formula. And I already showed you a quadratic formula, so I'm just going to kind of go straight to the answer for you, because I think we've already done that, but it's 8 plus or minus I root 17. I will let you know they wrote it as square root of 17 and then the I on the outside, which I don't like, but it's all right. Oh, distance and midpoint formula. So this goes way back. Distance formula, and I'm not going to do this whole one. It's not too hard. The distance formula is the square root of, you subtract your x's. So x1 minus x2 squared plus y2 minus y1 squared. And literally just, use your calculator. Just take your x's and type it in with all the parentheses. We did this in the beginning, like -8 minus 10 squared plus 9 minus -8 squared. And let the calculator do all the work. And you should end up with square root 35. And just leave it like that. Midpoint says it's a midpoint, so it's a coordinate. It's an x and y. So it says add your x's and divide by 2. Then add your y's and divide by 2. And that's all you would have to do. So you'd add your x's, so -8 and 10, and divide by 2. And then add your y's, 9 and -8, and divide by 2. And that'll be 3 halves and 1 half. Is that what it says? 1 half and 1 is what I'm getting. -8. Yes. 1 1/2. 52. Evaluate the discriminant. Oh, discriminant's easy. And predict solutions. Discriminant is b squared minus 4ac. So if the b squared minus 4ac equals 0, you have one rational solution, one real. If b squared minus 4ac is less than 0, you got 2 imaginaries. And if it's b squared minus 4ac is greater than 0, you have 2 rationals. And so that's all you have to do. You just remember this is your b. So b squared would be 16 minus 4 times 1 times c is 4, which is 0. So that means you have 2 rationals. And that's the multiple choice, which will be there. Okay, last question. But beside the other one that I'm probably going to do anyway. Domain and range. We know this. Domain. How wide is this thing getting? Well, it starts at 2 on the x. So it's going from 2 to infinity. Range. How tall is this thing getting on the y-axis? It's 0 on up to infinity. All right. Now, let me just take 1 minute to go back. I thought I was going to be really long, but I kind of zip through it. Where is it? Where is it? 26, there it is. Okay. You just bear with me. I'm going to do this one, and I promise this will be it. I'll just make sure we got this in and done with, okay?